Hey YouTube, I've purchased recently this TL866 programmer, and I've purchased it off eBay so that I can easily program my EEPROMs for the Z80 build. If you're not following, check out the playlists. But in any case, I thought since it has to do with the build and maybe some people not really sure how to use it, I'll make a video showing how to use it in a basic way and how to program different chips that I have here to demonstrate with. So this is the box it came from. It came off China. Everything is in Chinese, including the instructions. To start from the beginning, this is basically the programmer that I've got, and when I've set it up first, the CD that came with it didn't work, so I had to go to the website that is on the box, and I've downloaded the drivers from there, including the software. The first instructions, there was a short instructions in English on how to set it up and get it going. The instructions mentioned that there might be a firmware update required for this device, and I followed the instructions, but for some reason the program that came with it couldn't upload the firmware. So I searched online, I came to the EEV forum. Over there I found a thread. Some guy made a program to upload the firmware to it, and more than that, upload a higher version of the firmware so that you can also use this ICSP port that comes with it. Right now it's disabled, but you can open this box, remove this plastic, and solder your own port in there, and then you can use it, provided that you uploaded the firmware. On the box here you can see that this is version 866 CS. Don't know if you can read it, but I've set version A on it, which enables the ICSP port. And from there on it all worked fine, and I could use it. I could use it with the software that came with it, and that's what I'm gonna show you today. So if you purchased it and you're finding yourself at the same problem, go online, Google it, and you will reach a link in the EEV forum, and over there you will find the program, the firmware updater that you need to download. So moving on, this is the programmer. It's a mini pro version, and I'm going to show you today. As I mentioned, I bought it to program the EEPROMs for the Z80. So for demonstration, I have here an EEPROM, which I also purchased off eBay. And next I'm also going to demonstrate how to program an ATmega 32, the one that comes on the Arduino, how to set a bootloader on it so that you can use the actual chip with an Arduino, replacing the original chip, or just on your own Arduino setup, and use it, everything using this programmer. So we're going to start off first of all with this EEPROM. It's a 256K one, if I remember correctly, and it's a 29EE020, comes from SST. We're going to move shortly to the computer because over there most of the things happen. But basically you place the chip on the programmer with pin number 1, which is this one here. You can see according to the marking on the chip, you place pin number 1 on the closest port to the lever, and you lock the lever, and that's it. Basically the chip is in place. I'm going to connect a cable to it, and in the meantime we're going to move and see the computer, the software on the computer while I'm powering it on. right now it's powered on, and this is the software that came with it. And what you see on the software is basically you can see the memories here. It's divided by 16 bytes per row, and you can see that it's incrementing the rows by 16 each time. Right now you see there are all FF in here, and you can see that it's the wrong chip selected. I'm not going to cover all the functions here, they're not really that important, but we have here the open and save, reading the ID of the chip, filling the buffer, reading the chip, some help, calculator, you just press on it and you get the Windows calculator, which we're going to look into in a moment, and programming the chip, erasing the chip, testing it, and also an option of programming multiple devices. So first of all, I've placed the chip, and I'm going to select the type by going into this screen, and I can just search for it. So it's a SST. We're going to do it 29EE. There we go. So it's the version 20. I'm going to select it. It automatically opens up all the amount of space that we have on the chip, so I can just scroll through it. And right now we haven't read it, but the buffer is automatically by default just set to all, it's all empty, just FFs. Let's read it first of all and see what happens. So right now we're connected and we're powered on. So I'm going to read it. And you can see that we're reading it. We're reading it basically in the same way. If you watched the RAM-ROM video that I made explaining about those two with relation to the Z80 build, then you'll understand how this program actually reads the chip. It simply just goes through all the addresses, and on each address it reads the output, and that's the same way that it's reading it. So it read it, and it's empty. So you can see that again everything here is empty. Now if we want to program it, if we want to put our own software on it, we can simply just click on open, and here I have an example, just a Blink program from the Arduino examples, which will just cause an 80 mega to blink. It doesn't matter right now which program I'm going to put on it. Obviously, to be able to use that from the chip, you'll need something that can read it. But as far as data is concerned, the programmer doesn't care what you're putting on it. It will just write the values to the chip, and that's it. Once we load it, it asks us if we want to read it in a binary or in a hexadecimal. Usually they are in hexadecimal, and you will also see that on the ending of the file. If it's a .hex, then it's hexadecimal, and if it's .bin, then it's binary. I'm clicking OK, and this is basically our program. It's not that long, it's quite short, just causes the 80 mega to blink, but you can see here we have all the values. Everything you see here, that's what it looks like inside the memory. If I will just click program right now, and I will program it, then again it will go through all the addresses on the chip, and it will write everything that is in this buffer, including all the empty cells, or the cells that we're not using. So right now you can see that it's writing it, and if I exit and if I clear the buffer, and then I'm going to read it again. So right now I've cleared it, we're at address 0, everything is just empty, and we're going to read it again. We're going to be able to see that the buffer fills up with the values that came from the chip. So that's basically how you use it. It's quite simple when it comes to these EEPROMs. You can also manually change these things. So if I again I clear everything, and we're back at the shot here. I'm going to move this to the side for a moment, and I'm going to show you this page. Again, this page comes from the previous demonstration I did about the RAM-ROM chips, and it's basically what the program would look like inside the memory. At each address we have a single byte, and that's the same thing that you see in the software itself. We have the assembly commands, and for this example I just wrote here the values for each one of the bytes in hexadecimal. And if we go back to the computer, then I can just manually sit and type all these values. So I can type the first one, and the second one, the third one, and then the fourth one. Oops. Just like that, and just like that. And I can fill it all up. And I already did that, so I can go here and I can just go to my little sample program that you saw on the page a moment ago, and I will open it. And this is basically the program, not the program, but the few lines of code that you saw on the page, translated into their hexadecimal values, starting from address 0 and up until address 14, and the rest are all zeros. And I can write it to the chip, and again it will go through the entire all the addresses on the chip, and it will write whatever sits inside the buffer. And regardless of which code or which program you're putting on there, eventually you are the one that needs to make sure that the code matches whatever device or application this chip goes into. So again, we loaded it. I'm going to clear the buffer. I'm going to read the chip. And then we're going to see our little program starting at address 0 and ending at address 14, which is what you see right now. So that was a short explanation on how to program these EEPROMs. The next demonstration, I'm going to show you how to program an 80 mega chip. So I'm going to remove this chip from here. And I'm going to place the 80 mega chip. Again, we're placing it with the marking, just like it says here on the programmer. Pin number 1 comes closest by to the lever. We're setting it in. This chip, I cleared it. The only thing that I've set are the fuses to work with 16 megahertz. Didn't want to change that, but basically it's empty. And again, also with this one, we can just place any type of code that we can think of. The only limitation, if the program has any, it will say that there is not enough room on the chip that we loaded. But now I'm going to change the type of the chip. So I'm going to select an 80 mega. And we will need the 32 version. Do we have 32p? Here we go. We have 80 mega 328p, which is the one that I'm using right now. I'm going to select it. The buffer is all empty by default. We didn't read the chip or anything like that. We can read it. Let's try that one. So we're going to read this chip, and this one reads faster because this one, since it's a microcontroller, it's being programmed through serial data and not just by going through each one of the addresses. It's also faster, but again, we've read it and you can see that it's all empty. Once again, I can select a program. I can select, for example, this blink program right here, and upload it. And then if I connect the chip to place it in an 80 mega, in an Arduino, or just loose and connect the pin number 3, which sits in this specific code, then we're gonna get just a blinking effect. But I'm not gonna upload this code because we've already seen that with the previous chip. My goal in explaining this 80 mega one is that we can load a bootloader to it, and then we can effectively use the chip that I've programmed using this programmer, just place it in an Arduino and use it as the original chip that came with the Arduino itself. For that, there is a little bit more explanation. So I'm going to load a program here. And I've saved it from a previous chip. I simply took out the chip that was in the Arduino originally, removed it, placed it in the programmer, and just when it was empty, only with the bootloader, and I've basically saved the whatever was in the chip. And I got the whole setup for the chip the way that it needs to be for the Arduino. We can see here that the first section will be the code itself, the code that makes it do whatever. And at the very end of the chip, we will find the code that is responsible for the bootloader, so that the communication between the Arduino interface and the 80 mega can happen through the interface without any sort of external programmer again to upload the code to it. Now, the important thing about this is that if you just upload this code the way that it is right now, and then you take this chip and you place it in the Arduino or in your own Arduino setup, you'll find that you can't upload anything to it. It will not program the chip, and that's because, unlike the previous memory that you saw, the microcontrollers, they have fuse bits. These fuse bits are basically sort of a setup. We can set them up by going into this tab right here, which is the configuration. Right now, the only two bits that are set are these ones, and they are just by default through this program. But these bits will allow us to lock the chip. They will allow us to change the clock speed, for example, from 1 megahertz to 16 megahertz, use the internal one or the external one, save the boot data so that it doesn't get erased next time that the Arduino programs the chip and all that. So, as I said, I've looked at the previous 80 mega that I removed originally from the Arduino, and I've looked at the fuse bits, because if you don't program them in the same way, it will not work. So for the 80 mega that came from the Arduino, I need to set all of these fuses. So if I upload this program, I need to make sure that all of these are also set, so that it will actually work right. And now if I just write it to the chip, then at the end of this process we will get an identical chip, just like the one that comes on the original Arduino. So we've done that, and what I'm gonna do now is I'm gonna disconnect this, and I'm gonna remove this chip right here, and we don't need this page anymore. What I have here, I have here my own sort of Arduino setup. It's just an Arduino on a breadboard with a minimum components, so just the 80 mega itself. and this FT232 serial to USB module. I'm going to connect the chip, and if you're interested in the schematics for this setup, then you can just find it on the Arduino forum, and they show this exact example, only I'm using this is different. I bought it off eBay, and that's about it. I didn't add the voltage regulator because I don't need it. But right now, let me just connect this real quick. By the way, this FT232, I also purchased it off eBay. Cost me about $2, and it works great. I'm gonna connect it to the computer, so you're gonna see it power up. And right now there is nothing on this 80 mega. As I said, I only copied the original chip as it was empty. So what I'm gonna do now is I'm just gonna program it just using the Arduino interface, using this serial to USB communication. And since we have the bootloader on the chip, then everything should work fine just from the Arduino interface. There's only one thing. If we go back to the computer here for a moment, I'm going to open up the Blink sketch, which is just the example that comes with the Arduino. And I'm going to upload it. So I have here COM8. It identified it. If it didn't recognize it, then it would just be blank here and it wouldn't allow you to do anything. But it recognized it. The one thing with this specific setup, I don't know why, maybe it's just like that, but since in the original instructions they don't mention it, so I assume that the part that they're using there that comes from SparkFun and has more pins on it, maybe it carries out that function by itself. But to program this chip right now, I need to make sure that once the program starts to upload, I will see here a first flash for the receive communication. At that point, I need to reset the chip and then it will program it. So right now, as you can see, nothing happens. We have this LED here which is connected to pin number 13. According to the sketch, it should flash once we upload it. So let's try it and see if everything went right. I'm going to try to do it as best as I can, just synchronized. So right now I'm going to upload it. And once I see the first flash coming, I need to press the reset button once, and then it goes into programming mode. And there, as you can see, we've programmed the chip just using the Arduino interface. So basically what we did, we've loaded the bootloader using this device. We've set everything that this chip needs using just our generic programmer. And from there on, assuming just using this FT232 USB to serial communication device, we can just use it as a regular Arduino with that small instruction of you need to reset it in order to activate the programming feature. So that was it. You're gonna see if anyone will have questions, then I'm going to reference this video once I go further with my Z80 build. But I hope you liked it, and I hope that it showed you the way to go about it if you purchased a similar one. And if you're interested in the Z80 build, which uses these EEPROMs, which I've bought this for, again, just check in the playlist. And if you like it, then consider subscribing. Thank you for watching, and I'll see you next time.